Okay, so we are going to do some cylindrical coordinates and triple integral. Boards go up, please. I got a lot of problems, so hopefully you walk out of this feeling pretty good about what cylindrical coordinates are and how we integrate and what tricks we can take. So, first thing I want you to do is kind of familiarize yourself. Find the cylindrical coordinates for A, the paraboloid z equals x squared plus y squared, and B, the cone z equals z squared equals x squared plus y squared. So, remember you've got a couple conversions. It's like your polar conversion. So x squared plus y squared is r squared, x equals r cosine theta, y equals r sine theta. Not that you have to do all that with these. It's quick if you do it right. Then z is just z. So pause, go ahead, do it. Okay, bam, we got some answers. So all I do is anytime I got an x squared plus y squared, I just change that to an r squared, right? So x squared plus y squared is r squared. So for part A, I just get z equals r squared. And that gives me a paraboloid. You should see that this is a paraboloid in rectangular. And if you're convinced of that and you're convinced of this, then this should also be a paraboloid. Part B, pretty similar. I take z equals r squared, right? Because x squared plus y squared is z squared. Sorry, z squared equals r squared. And then when I square root both sides, I get z equals plus or minus r. Remember, the r is always positive when we're dealing with cylindrical coordinates. So z equals plus r would be the upside of this cone, and z equals minus r would be the downside of this cone. If you talk about this equation here, in rectangular, then it accounts for both halves. This would be top half and bottom half, depending on if it has a plus or a minus. Okay, hopefully you go with that. Let's do C and D. So C should be pretty straightforward if you understood A and B. And D is a little bit different and not quite the same style of conversion, but still pretty straightforward once you see it. So hit pause, try both of those. All right. So part C, maybe I will zoom out. Part C was x squared plus y squared is 9z, or sorry, x squared plus y squared plus 9z squared equals 9. Do you know what that is? This would be a ellipsoid. And I'll let you think about what the radius would be in different directions. Z would be plus or minus 1, I think, and then the x's and the y's would be plus or minus 3, I think. Yeah, 3. All right, so anyway, what I get is the x squared plus y squared here. Zoom out just a little bit more. The x squared plus y squared here turns to an r squared. The 9z squared stays as a 9z squared, and the 9 stays as a 9. You could solve for one of these if I wanted z equals. I could move the r over, or if I wanted r equals, I could move this thing over and square root and have a plus or a minus, but I just decided to leave it like that. So the next one, we're going to use that the polar conversion that we use all the time. X is r cosine theta, y is r sine theta. So I get 2r squared cosine squared theta minus 4, where you may say, what? Well, look, x squared. If I square that, I get r squared cosine squared. So I get 2r squared cosine squared. Same thing, minus 4r squared sine squared plus 4z squared. You could do some manipulation with this, but the minus kind of gets in the way, so it's totally fine to just leave that like that. Okay, so hopefully you're, oh no, I got one more that I want to do here. Okay, here we go. Z equals 10 minus root x squared plus y squared. I want to know what is that shape in 3 dimensions and what is the equation in cylindrical. I think the second part of that equation is actually easier to answer than what's the shape, but you should be familiar with this from some of the examples from the last day. So hit pause, see if you can answer both those questions. Okay, here comes the answer. I'll actually do the second part first. Well, this is r squared. When I square root it, I get minus r, right? So when I square root r squared, I get r. So this is z equals 10 minus r. Um, so look here, if I move this 10 over and square both sides, oops, um, then it has the same form as this, z equals z squared equals x squared plus y squared, right? Except for I have a z minus 10, right? Well, if this guy up here was a cone, then this guy down here should also be a cone. So once we determine that it's a cone, right, you should see that like letter B, it's the bottom half of a cone. Oh, it's the bottom half because of that minus, right? The point of this cone is I can plug in 0, 0 because there's no shift side to side on the x's and y's. Plug in 0, 0 and I get z equals 10. That's the point of the cone. It's the highest value that z is going to be if I'm subtracting a square root because that square root's always going to come out and be positive. So it's got to be the pointy top. And then the next question might be like, what does the base look like, right? Well, if I or sorry, where does it intersect with the XY plane, which this is x-axis, y-axis, z-axis. You should be familiar with that. Well, I can plug in z equals 0. If I give a height of 0, then we're in the xy plane. And if I do that, I get a 0 here. I can move that over to the other side and square both sides and get x squared plus y squared is 100. And that is a circle of radius 10. So it's got a slope of 1 coming down the sides of the cone here because it goes up 10 and then out to 10 all radially. It intersects the xy planar equals 10, and I would do z equals 10 minus r. So hopefully you're good with those. I'm going to end this video here and give your next problem in the next video.